Hello friends, welcome to the video lecture series of Engineering Mathematics 2. In this video lecture, we are going to discuss a very important and interesting topic of Engineering Mathematics 2, that is curve tracing. And curve tracing serves a lot of application in life, testing and verification of wide range electronics instruments, or you may call it as the sensors also. Curve tracing serves application in orbital motion of the satellite, the rotational motion of any object where the curve tracing is used. In calculus also, the curve tracing is used to find out the area under the normal curve, area of the region. What is curve tracing? Curve tracing is nothing but the tracing the curve on the basis of some facts, on the basis of some characteristics. And those characteristics we are going to study. On the basis of characteristic and few points in xy plane, you can trace the curve. The first characteristic is the symmetry of the curve. Here with curve tracing, the three types of curve we are going to discuss. That is Cartesian curve, polar curve and parametric curve. If equation of curves are given in terms of x and y are Cartesian coordinates, then that curve is Cartesian curve. If equation of curve is given in terms of r and theta are polar coordinates, so we may call it as polar curve. Equation of curve is given in terms of parameter theta or parameter t, then that is parametric curve. Now what about the symmetry of Cartesian curves? The symmetry about x-axis, symmetry about y-axis, symmetry about any line we can find. So what about the symmetry about x-axis? In equation of curve, all the terms in y are even power. Then curve is symmetric about x-axis. Symmetry about y-axis is what? In equation of curve, if all the terms in x are even power, then the curve is symmetric about y-axis. Symmetry about both the axes. In equation of curve, if all the terms in x and all the terms in y are even power, then the curve is symmetric about both the axes. Symmetry about the line y equal to x. In equation of the curve, how to check it? In equation of the curve remains unchanged by substituting x to y and y to x. Then the curve is symmetric about the line y equal to x. Then symmetry about the line y equal to minus x. How to check this symmetry? By interchanging x by minus y and y by minus x. If equation remains same, equation remains unchanged, then the curve is symmetric about the line y equal to minus x. Symmetry in opposite quadrant. How to check this symmetry? If the equation of curve remains unchanged on replacing x by minus x and y by minus y, then the curve is symmetric in opposite quadrant. The few curves I have taken to explain this characteristic. This curve, y square in bracket 2a minus x equal to x cube. If you look at this curve, all the terms in y in this curve are even power. Therefore, it is symmetric about x-axis. All the terms in x are not even power. Therefore, it is not symmetric about y-axis. All the terms in y are even power. Therefore, it is symmetric about x-axis. In the next curve, here all the terms in x are even power. No doubt there is single term is there. All the terms in x are even power. Therefore, it is symmetric about y-axis. In this equation of the curve, this is equation of circle with center 0, 0 and radius a. Here all the terms in x are even power. All the terms in y are also even power. Therefore, it is symmetric. This curve is symmetric in both the axes. Symmetric about both the axes, you can see. The next curve, xy equal to c square, this is the rectangular hyperbola. Here, if you replace x by y and y by x, then equation of the curve remains same. This is the rectangular hyperbola. Therefore, this curve is symmetric about the line y equal to x. This is the equation of curve, this is the curve, and y equal to x is this line which makes angle of 45 degree with x-axis. This rectangular hyperbola is symmetric about the line y equal to x. See, this much part is symmetric with this part, and this much part above the line and this much same part below the line. Means this rectangular hyperbola is symmetric about the line y equal to x. Next curve, y is equal to x cube. Okay, nature of the curve also I have drawn here. Replace y by minus y, replace x by minus x, and on solving this, again same equation I am getting, minus minus gets cancelled. y equal to x cube again I am getting. Means equation of the curve remains same by replacing y by minus y and x by minus x. Therefore, this curve is symmetric in opposite quadrant. So if you look at this is the first quadrant, this is third quadrant, this is second and fourth. The curve present in the first quadrant, the same curve is present in the second quadrant. Okay, its mirror image is there. Next curve, a square y square minus x square. Here all the terms in x and all the terms in y are even power, therefore it is symmetric about both the axes. Here in this equation, all the terms in x are not even power. See, the power of x is 1, this term is not even power, term in x. All the terms in y are not even power, therefore it is neither symmetric to x-axis nor symmetric to y-axis. Then this curve is symmetric about x-axis because all the terms in y are even power. All the terms in x are not even power. Here also, all the terms in x are even power. All the terms in y are even power. Therefore, it is symmetric about both the axes. In last equation, all the terms in x are even power. Therefore, it is symmetric about y-axis. All the terms in y are not even power. Therefore, it is not symmetric about x-axis. It is symmetric about y-axis. Now, the next characteristic of the curve, that is the point of intersection. Okay, when you trace the curve, it may intersect with any line. It may intersect with x-axis, y-axis or any line. Or it may pass through the origin. It may touch the origin. The x-intercept you can easily find out by putting y equal to 0 in equation of curve. Y-intercept also you can easily find out by putting x equal to 0 in equation of curve. Now, whether the curve passes through the origin or not, how to check it? If equation of the curve does not contain a free constant term, then curve passes through the origin. Okay, these 0, 0 are the coordinates of the origin. I repeat, if equation of the curve does not contain free constant term and that constant term should be non-zero, then curve passes to the origin. Now, this curve I am going to draw y square equal to 4ax. This is the parabola. In previous years, many times you use this curve. This is y-axis, this is x-axis, and equation of this curve, all even power terms are there. Therefore, it is symmetric about x-axis. Okay, this is the parabola, and this parabola passes through the origin. Why? Because it has no free constant term. Y square is variable term, 4ax is variable term, and free constant term is not there. Therefore, it passes to the origin. Now, y square plus 4ax, the next parabola, y square equal to 4ax plus 4. Then this parabola I am not going to draw, but this is variable term, this is also a variable term, and this is free constant term. And that constant term should be non-zero. Free constant. Therefore, this curve does not pass through origin. It will not pass through origin. If equation does not contain free constant term, then it passes through the origin. And if curve passes through the origin or curve touches to the origin, then equation of tangent at origin to the curve you can find out. So how to find out? Tangent at the origin, it is obtained, which tangent at the origin can be obtained by equating lowest degree term, or there may be more than one term, lowest degree term with 0. So some examples I have given. In examination, the one problem may be asked on this. Equation of tangent to the curve at origin. Now in this curve is passes through the origin because there is no free constant term. Just I am going to simplify it. Xy square equal to x cube. I open the brackets. And what is the lowest degree term? The degree of this term is 2. Degree of this term is 3. Because degree of x is 1, degree of y is 2, and addition of this is 3. Degree of this term is 3. And the lowest degree term is 2ay square. So what I am going to do, this lowest degree term 2a y square I am equating to 0, and therefore y square is equal to 0 by 2a means y square equal to 0. So y square equals 0 means y equal to 0 and y equals 0. Y equals 0 and y equals 0. This y equals 0 is the equation of x-axis. Then what is tangent to this curve at origin is x-axis. Tangent to this curve at origin is x-axis. But if you look at the tangents, then we have two tangents, y equal to 0 and y equal to 0. And these two tangents are same. So this point is called the cusp point, This point is called the cusp point. Okay, this type of situation is there. I am not exactly drawing the curve, but in order to explain the cusp point, I am going to tell you. Okay, this is the part of the curve, and tangent to this part of the curve is x-axis, y equal to 0. And tangent to the same curve is this another part of the curve, this single curve, and tangent to this part of the curve is again y equal to 0. Means we have two tangents, but they are same. Y equal to 0 is a tangent and y equal to 0 is a tangent. These two tangents are overlapped, you can say. So this point is cusp point, is the cusp point. Now, the next problem, we are going to find out tangent at origin, equating lowest degree term to 0. Just I am going to simplify it, x cube minus x. Degree of this term is 1, degree of this term is 3, degree of this term is 1 again, and the lowest degree term, there may be more than one lowest degree term. Lowest degree term, I am writing y is the lowest degree term and this minus x is the lowest degree term. Therefore, y is equal to minus x is the line and which is tangent to the curve at origin. Tangent at 0, 0 means tangent at origin. Again the same thing here. This is the equation of curve given to you. The degree of this term is 3, degree of this term is 3, degree of this term is 2 because degree of constant is considered to be 0. 0 plus 0 plus 1 plus 1 is 2. The lowest degree term is 3axy. 3axy I am equating to 0. Means xy equals 0. xy equals 0 implies x equal to 0 or y equals 0 or both of them equal to 0. So these are the tangents at origin. Tangents to the curve at origin. Now tangent to this curve at origin, I am going to simplify it 4y square minus xy square. Here x square into x is x cube minus 4x into x plus 4 into x. Now the lowest degree term, degree of this term is 2, degree of this term is 3, degree of this term is 3, degree of this term is 2, degree of this term is 1. So what is the lowest degree term here? The lowest degree term is 4x. Therefore 4x equal to 0. 4x equals 0 means x equal to 0. And x equal to 0 is what? Y-axis. X equal to 0 is the equation of y-axis. So this is tangent at origin. Tangent at origin is y-axis. Now, the next important characteristic is asymptote to the curve. This what is meant by asymptote? Asymptote is the line which meet the curve at infinity. And there are two types of asymptote we are going to study here. That is asymptote parallel to x-axis and asymptote parallel to y-axis. So firstly, the asymptote parallel to x-axis. So how do you get asymptote parallel to x-axis? Asymptote parallel to x-axis is obtained by equating coefficients of highest power of x term with 0. When we found tangent at origin, we equated lowest degree term to 0 directly. Here we are not equating lowest degree term to 0 or highest degree term to 0. Here we are equating coefficients of highest degree term in x for asymptote parallel to x-axis. We are equating coefficients of highest degree term in x to 0. We are equating. For example, yx square equals a square a minus y. This is the equation of curve. You will be given any curve in the examination. This I am going to simplify it. Simplification means opening the brackets only. Highest degree term in x. Which one is the highest degree term? Only single term is there. There is a single term in x. Highest degree term is this one because there is a single term. And coefficient of highest degree term in x is y. Therefore, equation of an asymptote. How do you get equation of asymptote? If you equate coefficient of highest degree term in x to 0, means equation of asymptote is y equal to 0. And y equal to 0 is what? X-axis. So, this type of MCQ will be definitely there in the examination. You will be given any curve and find equation of asymptote. In order to explain this curve I am going to draw in this way directly. This is the curve. This red curved line is the curve. And this dotted line, this line is asymptote to this curve. Means x-axis is asymptote to this curve. Now asymptote to the equation of curve which is parallel to x-axis. This I am going to simplify y square a square y square x square. This equals x square a square. Is it? Now we are going to find out asymptote parallel to x-axis. What we have to do? Highest power terms in x. How many terms in x? This term containing x, this term containing x. And highest power is 2. Both the term having the terms in x which has power 2. And its coefficients we are going to equate. Then equation of asymptote, how do you find? Equation of asymptote parallel to x-axis. This is important. How to find out? Equating coefficients means y square. Due to this equal to sign, I am putting here equal to a square. And y square equal to a square, if you take square root of both the sides, then y equal to plus a is the equation of asymptote parallel to x-axis, and y equal to minus a, equation of asymptote parallel to x-axis. Okay. And this curve, this I am going to draw because later on we have to trace this type of curve. Because in order to explain the asymptote parallel to x-axis, I am going to draw the curve directly. This is y equal to a, this y equals minus a. This line is y equal to minus a line, and here this line is y equal to a line. And the curve is like this, These two lines, dotted lines, are asymptote to the given curve. Now asymptote parallel to x-axis we found. Now asymptote parallel to y-axis. It is obtained by equating coefficients of highest power terms in y with 0. Some curves I have taken. This is the curve. Just I am going to open this bracket x square y square equal to, you can shift it on the left hand side also if you want, asymptote parallel to y-axis. Here our concern is the y term. How many y terms are there? This is y term, this is y term, 2 terms are there. And the highest power of y is 2. And their coefficient, equation of asymptote, how do you write? Equation of asymptote parallel to y-axis, how do you find? Equating coefficient of y square. Coefficient of y square is a square and coefficient of y square is here 2, 0. Means x square equal to a square. So x equal to take square root of both the sides. x equal to a is asymptote, x equal to minus a, another asymptote. Means there are two asymptotes to these curves. The next problem, x y square, this I am shifting on the left hand side, multiply this by this and shift it on the left hand side, or you can keep it on the right hand side also, it is your choice. X a square, asymptote parallel to y axis. How many y terms are there? Only single y term is there, and coefficient of y square is x equated to 0. This is asymptote parallel to y axis, and x equal to 0 means y axis, because in option you will be given x equal to 0 or y axis. X equal to 0 is the equation of y axis. The same problem, similar kind of thing. You can open the brackets, say x square y square, then x square b square, a square y square and a square b square. A square b square is there on the right hand side, you may cancel it, not necessary. Now asymptote parallel to y axis I want. How many y terms are there? This is y term, this is y term, and highest power y terms are 2. Highest power is y square 2, and here highest power is 2. Its coefficient I am going to equate x square minus of a square, that I am going to equate to 0. X square equals a square, therefore x equal to plus a and minus a. These are the equation of asymptote to this curve. Now here 2ay square minus xy square minus x cube. I am going to find out asymptote parallel to y axis. How many y terms are there? 2. And the power of these two terms are same. I am talking about the y term. Equating coefficients to 0. 2a minus x equal to 0. Therefore, x equal to 2a. This is asymptote parallel to y-axis. Very quickly, next problem. 4y square minus xy square. Then shift this on the left hand side. Is x square into x is x cube. Shifting on the left hand side. Then minus 4x into x. Minus 4x square I am shifting on the left hand side. Plus 4 I am shifting on the left hand side. How many y terms are there? This is the y term, this is the y term. Equate coefficients of y term, and this is the highest power term in y. Therefore, asymptote, equation of asymptote parallel to y-axis is what? 4 minus x equal to 0. Means x equal to 4 is the line which is asymptote parallel to x-axis to this line. The next characteristic is region of absence to be given. As region of presence means what? The region of presence means the region in which the curve lies, and region of absence means the region of xy plane in which curve is absent. The region of absence we are going to find. What is the region of absence? It is a region in which the curve does not lie. Now, two MCQs I have taken here, first MCQ and second one. The region of absence for the curve x square y equals a square a minus y is dash dash, and the options are also given. First option, second, third and fourth. 4 options are given. Now, how do you find out the region of absence? Region of absence, once again I tell you, the region in which curve is absent. Now, if you look at this equation very, very carefully, here there is a single term in x and single term in x square, you can say. So here, what I am going to do, I am expressing x square, I am writing x square in terms of y, or you can write y square in terms of x also. But that should be explicit expression, means x square on the left hand side and all y terms on the right hand side. On the right hand side we don't want x. X square explicitly we express in terms of y. Now x square is this much. So for which values of y x square is negative? If you look at this right hand side very carefully, if y is greater than a, if y is greater than a means y is equal to 2a, y is equal to 3a, y is equal to 4a, y is equal to 5a, 6a and so on. If y is greater than 2a, then this term, see, y is greater than a, then this term will be negative. A minus 2a is negative, a minus 3a is negative, a minus 4a is negative. Means y is greater than a, this term will be negative. Here a is positive. Okay, here it is written a is positive. When y is greater than a, then this is positive and a square is positive. This square a is positive. Then positive multiplied by negative divided by positive is what? Negative. Here x square is negative for y greater than a. Therefore, curve does not exist for y greater than a. Now, is there any other range, or you can say the region or range of y for which x square is negative? Any other range? If you look at this function, if y is negative, see, x square equals a square, once again I am going to write, if y is negative, means less than 0, then this will be negative. A square is positive. If y is negative, then minus minus will be plus, means this much part will be positive again. And positive by negative will be negative, means x square will be, finally, x square will be negative. For y less than 0, x square is negative, curve does not exist. For y greater than a, x square is negative, curve does not exist. Okay. Means what is the correct answer for y greater than a and for y less than 0? This is the correct answer. For y greater than a, and this much is a, no? For y greater than a, this much is a, this much is a and this much is a. For y greater than a means y is equal to a line is this line. And y greater than a means what? Y greater than a means the values of y above this horizontal line. Means above this line y equal to a, y is greater than a. Okay, this dotted portion is y is greater than, and y less than 0 means below this line. Y greater than 0 means above horizontal line, above x-axis. Y less than 0 means this. Means this dotted portion is y less than 0. This dotted portion is y greater than a. This much distance is a. So this is the region of absence. Means in the dotted portion, curve will be absent. Curve will be absent in dotted portion. In this much portion only. In this much portion, the curve will exist. The region of absence we found y greater than a and y less than 0 is the region of absence. Second MCQ, the region of absence for the curve y square in bracket 4 minus x, x minus 2 whole square. So if you look at this equation of curve, it is simple to write y square in terms of x in this way. This I have shifted on the right hand side. Now, for which value of x now? Y square is negative. For which value of x, y square is negative? So if you look at it very carefully, so this bracket is always positive. See, this is the square bracket. For any value of x, this is positive, because square bracket is always positive. For any value of x is positive. Now, for which value of x, x by 4 minus x is negative. If x is greater than 4, x is greater than 4 means x is equal to 5, x is equal to 6, x is equal to 7, x is equal to 8 and so on. For x greater than 4, this will be negative. This will be negative. And when x is greater than 4, means 5, 6, 7, so this will be positive because x is greater than 4. The positive by negative will be negative. The y square is negative for x greater than 4. Now, is there any other region or any other set of points of x for which y square is negative? Then look at this very carefully. Once again, I am going to write equation of the curve here. It is 4 minus x. Okay, this is always positive. This square bracket is always positive. Okay. Now, the nature of y square is depend on x by 4 minus x. For which value of x, y square is negative. If you look at this x by 4 minus x, if x is negative, then negative means less than 0. This will be negative. And if x is negative, negative means minus 1, minus 2, minus 3. This will be positive. Then negative by positive, this square bracket is always positive. Negative by positive is negative again. So y square is negative for x less than 0. Therefore, x less than 0 and x greater than 4, x less than 0 and for x greater than 4, it is the region of absence. The region of absence means in this region curve will not lie. Okay. In short, I am trying to explain here. This is x-axis, y equals 0. This is y-axis, x equals 0. And x greater than 4. X greater than 4 means this is 1, 2, 3, 4 like this here. This is x greater than 4. Okay, x equal to 4 here. X is equal to 4. X greater than 4 means which region? This dotted region is x greater than 4. On the right hand side of the line x equal to 4. This region is x greater than 4. And x less than 0 means this line y-axis x equal to 0. On left hand side of the line x equal to 0, here we have x less than 0. On the right hand side of this line, here we have x greater than 4. Means our curve will lie between these two lines. Okay, this is the region of presence you can say, and dotted region is the region of absence. In this way, the few characteristics of curve tracing. In next lecture, we will discuss how to trace the curve. We stop here. Thank you very much.